Hello, everybody. I just want to give you some quick tips on inverse functions to answer some questions that have been coming up pretty commonly. So the first thing I want to mention is that it is often very easy to check that an inverse function exists. So say that there is a function f inverse, but impossible to write down an explicit formula for it. Like sort of to write it down in sort of an explicit way using simple, well-known functions. So a good example that looks like sort of an example you encounter on your homework assignment is this function f of x is equal to x cubed plus 3 to the x. So if I differentiate this, I get f prime of x is 3x squared plus ln of 3 times 3 to the x. And that's always greater than 0. So this function, like any function that has a derivative that's always greater than 0 or always less than 0, is invertible. It's sort of strictly monotonic is the word the book uses. So f is invertible. But I mean, some others essentially no way you can sort of solve for y. So if I try to sort of compute f inverse, well, I would start by saying y is equal to x cubed plus 3 to the x. Sorry, to solve for x, I guess is the issue. So I write down y is equal to x cubed plus 3 to the x, and then I can't solve for x as a function of y. So no matter how you try to manipulate this equation, like take square roots or logs or something, like you just sort of the terms don't play well together. Like it's really hard to write down just an explicit formula for x as a function of y using this, even though sort of this result that sort of a strictly monotonic function is invertible tells you there is an inverse function. Like there's just no way to like find a good formula for it. Okay, so that comes up quite a few times. So I want to discuss sort of what you do then in that situation, and I'll do that in a minute. But first, I just want to talk about when it is possible to invert a function. So to answer this question, like when can we compute an inverse explicitly? And well, we need to be able to solve for y in terms of x. And there are really only a few sort of common types of examples where it's always going to be easy to do. And then of course, there will be like ad hoc simple examples where you'll be able to do it. Like if the sort of function is pretty simple and we've already introduced like related inverse functions. But somehow there aren't too many cases right now where we can just sort of do this. So the two examples that sort of come up a lot on your homework are linear functions. So that's like for example, like f of x equals 3x plus 2. Well, if I sort of put y is equal to 3x plus 2, and I want to solve for x in terms of y, I get, well, y minus 2 is equal to 3x. So y minus 2 over 3 is equal to x. And so that means sort of f inverse of y is equal to y minus 2 over 3. So that kind of linear function is pretty easy to compute an explicit formula for f inverse. Also for quadratic functions, you can do this. Like for example, if I have f of x equals x squared plus 2x plus 3, well, that's not invertible if I think of its domains as being the whole real numbers. But if I look at the domain x greater than -1, then you can check sort of the derivative on this will always sort of be positive. On this domain will always be positive. So it is invertible on the domain x greater than -1. And so we want to compute this inverse. Well, we have y is equal to x squared plus 2x plus 3. And so I want to rearrange that as follows. So this is sort of a little tricky. I want to rearrange that by moving everything over to the right-hand side. So also do 0 is equal to x squared plus 2x plus, I'm going to write this as 3 plus y, or sorry, 3 minus y over here. And now I want to use the quadratic formula. So, I mean, this is saying x is sort of a root of this sort of quadratic polynomial. And I have a formula to sort of compute those roots. So I get sort of the quadratic formula gives me x is equal to minus 2a, so minus 2 plus or minus the square root of b squared. So b is 2, so that's 4, minus 4ac, so a is coefficient 1, c is sort of this constant term, which has a y in it. So here's where your y is showing up. So 3 minus y. Good. And then all over, so yeah, sorry, this is sort of minus b. I think I said minus 2a. So minus b, so minus 2 plus minus the square root of b squared minus 4ac, all over 2a. So that's over 2. This is equal to minus 1 plus or minus the square root of 1 minus 3 minus y. So if I sort of simplify that, I get 1 minus 2 plus y. Okay, so that's sort of what the quadratic formula gives you. And then to get f inverse, well, you have to choose whether it should be plus or minus here. But we're supposed to be getting something that's sort of greater than minus 1. So we should do plus here. So plus, and so then f inverse of y is minus 1 plus square root of minus 2 plus y. Okay, good. And so somehow this will be, this square root, this will be positive when y is sort of greater than 2. And that's sort of exactly what the domain of this f inverse function should be. Because if you look at sort of, if you think about it, you see like what f of x does on the domain x greater than minus 1. Well, it sends sort of f of x on x greater than minus 1 will sort of be always greater than 2. One thing I want to point out in these examples, and so yeah, these are sort of basically the 2 times you can explicitly compute an inverse. One thing I want to point out in these examples is that sort of I've written f inverse y. Sometimes your like homework or assignment will ask sort of for f inverse x. I mean, that's not the same x as sort of in f. That's just because we like to sort of call the variable in a function x. So you just sort of replace y with x after sort of computing f inverse y. So when you sort of, when a problem asks for f inverse x, like that x is not the same x as an f of x. It's just sort of a name for a variable. You compute it like sort of by doing this process here. And then once you have f inverse of y, you just change the name of y to x. Okay, good. So then, okay, so those are the times when you can explicitly invert a function. What should you do otherwise? So what do you do if you're sort of asked to compute like f inverse of 7 when you can't find an explicit formula for f inverse? And so that sort of comes up a lot in problems asking you to compute like the derivative of f inverse at 7. Because somehow we have, like, when we know what f inverse of a number is, then we have a nice formula for the derivative. Like if we know what, so like if so if a is equal to f inverse of 7, then we sort of have a formula that tells us that f inverse prime of 7 is equal to 1 over f prime of a. So this sort of comes up a lot when you're sort of computing these derivatives. So okay, if you're in this situation where you don't know how to compute an explicit formula for f inverse, like the only thing you can do to find f inverse of 7 is sort of just guess and check. So what do I mean by that? Well, you use this relation that saying f inverse of b is equal to a is really the same as saying f of a is equal to b for an invertible function. So you're just looking for some value of a that when you plug into f gives you b. So in this case, that would be sort of looking for some a that when you plug into f gives you 7. So if we go back to like this earlier example, if we look at like f of x equals x cubed plus 3x, x cubed plus 3 to the x, we saw this was invertible, but it's really basically impossible to solve this y equals x cubed plus 3 to the x for x in a nice way. So there's no way to write sort of a good simple formula for the inverse function. But I might still ask you to compute f inverse of 17. And so, okay, so to do that, you're just looking for some value x you can plug in for f of x that gives you 17. So you might compute, well, f of 0, that's 0 cubed plus 3 to the 0, that's 0 plus 1, it's 1. So that doesn't work. F of 1, let's maybe try it. Yeah, f of 1, that's 1 cubed plus 3 to the 1, so that's 1 plus 3, that's 4. Okay, that's not 17, so keep on going. Maybe like f of minus 1, That's -1 cubed plus 3 to the -1. So that's -1 plus 1/3. That's -2/3. That's not what we're looking for. Let's try f of 2. So now that's 2 cubed plus 3 squared. That's 8 plus 9 is 17. Aha, that is what we're looking for. So f inverse of 17 is equal to 2. So that's sort of the process you can use, this guess and check process, when you sort of don't have a way to compute an explicit formula. Okay, I will stop there, but those are my tips.